Hey friends, today we'll see about velocity analysis. Actually, in kinematic analysis, it can be categorized into dynamics and kinematics. And kinetics, in kinematics, we can categorize position, velocity, and acceleration. Meanwhile, kinetics may be classified into second law base and impulse momentum and work and energy. Further, the Newton law can refer into stresses further in design. So, in graphical method, we have to analyze position, velocity, and accelerations at all. So, we need to know dynamic forces to be able to compute stresses in the components. Dynamic forces are proportional to acceleration, that is second law Newton. Goal shifts to finding acceleration of all the moving parts in the assembly. In order to calculate acceleration, need to find the position of all the links for all increment in input motions. Differentiate the motion equations to find velocities different again to get accelerations. The velocity analysis. Velocity is the rate of change of position with respect to time. It however the analysis into category. There is graphical method and vector loop method. I have focused on only graphical method. It have two sets, that is relative velocity method and instantaneous center method. Velocity of any point on a link with respect to another point on the same link is always perpendicular to the joining these points on the configuration of space diagram. So velocity analysis with respect to relative velocity analysis, these are the things to be considered. Take some convenient point O known as the pole. Through the O, draw OA parallel and equal to velocity, the point A, to some suitable scale. Through A, draw a perpendicular to AB. This line will represent velocity of B with respect to A, that is VBA. Though O, draw a line parallel to VB intersecting the line of VBA at B. Measure OB, which gives the required velocity of point B to the scale. So this is the thing, the velocity analysis with respect to instantaneous center method. Complex motion is a case of pure rotation. As the position of link AB goes on changing, so does the center I, about which AB is assumed to be rotating. Hence the name instantaneous center. The locus of all such instantaneous centers is known as centroid. A line drawn through an instantaneous center and perpendicular to the plane of motion is an instantaneous axis. The locus of instantaneous axis is known as axoid. Axis plus center, that is equal to axoid. Velocity analysis, that is instantaneous center method. Locating an instantaneous center rotation and its uses, just two directional velocities help locate the instantaneous center rotation. One complete velocity, that is magnitude plus direction, one other velocity direction, helps find velocity of any other point. VA by AO is equal from the picture. VA by AO is equal to VB by BO is equal to angular velocity omega. So VA divided by AO is equal to VB by BO is equal to VC by CO is equal to omega angular velocity. The velocity analysis instantaneous center method. Locating instantaneous center of rotation, its uses also. So no relative motion between A and B. So VA cos alpha is equal to VB cos beta. So VA by VB is equal to cos beta by cos alpha. we can write is equal to sine 90 minus beta divided by sine 90 minus alpha. Lamy's theorem to triangle ABI. So AI divided by sine 90 minus beta is equal to BI divided by 90 minus alpha. This AI by BI is equal to sine 90 minus beta divided by sine 90 minus alpha. So VA by VB is equal to AI by BI. So VA by AI is equal to VB by BA is equal to angular velocity. So next we move on to number of instantaneous centers, that is equal to number of possible combinations of two links, that is equal to number of combinations of n links than 2 at a time. So capital N is equal to n into n minus 1 divided by 2, where n is equal to number of links. So instantaneous centers type, first one fixed, remain in the same place for all configurations of the mechanism. Second one permanent, change of position but the nature of joint is permanent. Third one neither fixed nor permanent. Primary instantaneous center rotation, that is primary, it have fixed and as well as permanent. Then neither fixed nor permanent is a secondary instantaneous center of rotation. So what are the rules for locating instantaneous centers? For two links connected by a pin joint, the instantaneous center rotation lies on the center of the pin. That is the link 1 and link 2. So I12 is the center point of the pin. When the two links have a pure rolling, that is no slipping contact, the ICR lies on their point of contact. Two lines have pure rolling, no slipping contact. ICR line on the pure point of contact, where the 2 points meet. This is the point of I12. Then ICR means instantaneous center of rotation, has at infinity, and each point on the slider has the same velocity. The ICR lies on the center of curvature of the curvilinear path at that instant. The ICR lies on the center of curvature, which being the center of the circle is fixed for all configuration of the links. Unhold Kennedy for 3 center line in theorem. 3 links A, B and C having relative plane motion. So capital N is equal to n into n minus 1 divided by 2 is equal to 3. Unhold Kennedy's theorem. If 3 bodies move relative to each other, they have 3 instantaneous centers and they lie on the straight line. So IBC must lie on the line joining IAB and IAC. Consider IBC lying outside the line joining IAB and IAC. Now IBC belongs to both links B and C. Consider link BC, link B. So VBC must be perpendicular to the line joining IAB and IBC. Consider IBC and link C. So VBC must perpendicular to the joining IAC and IBC. But IBC is a unique point and hence regardless of whether it link B or C, it should have unique velocity, magnitude and direction. This is possible only when the 3 instantaneous centers, namely IAB, IAC, IBC, lies on the same straight line. The exact location of IBC on the line IABAC depends on the direction of magnitude of angular velocities of B and C relative to A.